Hello and welcome to this deep tech interview with Swissbit for Mauser. I'm your host Stuart Cording, the electronics reporter. Some in the embedded systems industry still think that obscurity delivers enough security. Because the technology is complex and the tools needed to attack it are specialised, the effort required will simply put people off. However, even if that line of thinking held any truth, it's even less true today. Tools like the Flipper Zero can be used to hack RFID access systems with ease, and if your Wi-Fi password is stored in plain text on your security camera, well, someone will just steal it to gain access to your network. Someone who knows all about implementing good security is Roland Marx, Senior Product Manager at Swissbit, and he joins me to explain how excellent security can be implemented in a commonly used storage medium, the SD card. So, welcome Roland, nice to have you here with me today.
Hi Stuart, thanks to be here.
Now, we've always sort of assumed embedded systems are pretty secure because they're often physically challenging to access, and the knowledge required to hack them, the debug tools, accessing serial buses and so on, that all seemed like hard work. Have we got any better?
Yeah, it's a hard question. So, and as like you said, so it might totally depend on what device you're looking at, what assets are on this device, like what an attacker could gain from it. And very often the owner of such a device does not really know what assets he might have. So he might have his passwords and so on, that he might be aware of, but also that an attacker could just use a free internet connection, for example, if he just would attack this device. So it depends, but generally I would say so. It's not really. It did not really increase much in security. So we don't see security by design or by default in many systems right now. But due to this fact, actually, the regulations are kicking in, and so I hope this will change in the future. But we can also have a discussion on that as well, and also like one thing. So I just have like certain different kind of devices here. So like DIN rail computers, whatever that are in your production, or if you have like really cheap smart home devices. So they all have different levels of security, different things that you might want to have protected inside of this device. And on the other side, you also always have usability. Yeah, so it must be as easy as possible so that the consumer or the buyer will buy. And that's mainly also always a challenge for system designers. So also having security versus usability in mind.
The industry now seems to realise we need proper security. What have they been putting in place?
Yeah, so actually in the last years we have seen some regulations already. Yeah, so for example for automotive industry, so like several years now. So after these GPEGs and so on, you see that security became mandatory, and you see it change somehow in the industry. So devices or security gets more thought about the overall life cycle of these products. And so on, but you also like, well, so I'm also a security consultant, and so many companies I talk to and ask them whether they do secure boot, for example, for their products, and they said, yeah, we could do, but actually it would make the product a little bit more expensive because it just needs like some minutes or seconds longer in the production process, because you have to enable something, you have to generate keys and so on. And sometimes the customer, the end customer, is not willing to buy a product if it's a little bit more expensive. So this is really, this is really a problem. Yeah. So you see some regulations. You know the industry would be ready for most of the things, but at the end it would raise the costs a little. Yeah? And so for automotive, I think it worked. Industry, they already have standards, and like if you're in the critical infrastructure sector, so there you have to apply certain things. There are standards out there like the 62443. If you're looking into embedded IoT systems, like more for the consumers, then you have the 303645, for example, which is, by the way, really readable standard also for like normal developers, I would say. So it really has some good examples in it, and just tells you like how security by design could look like for an embedded device. And as you have brought it up here, so these are the two things that will happen in the very near future, at least for Europe. So there are worldwide activities going on to increase the cybersecurity. But here, this is a small focus for Europe. And so there are two things. So the RED on the left, the Radio Equipment Directive, this was, I think, brought to action or at least announced end of 2021, I guess. And it will get active in this year in August. And this is like for all the internet connected radio equipments. Yeah, so this is the category of devices where the thing is applicable to. And they now need to have some certain security features to protect the network, to protect privacy data if privacy data is somehow computed on these devices. And if you transfer money or store something with a monetary value, then you also have to use fraud protection. And until, I think, not 1 or 2 weeks ago, we finally got the standard, and that is officially announced by the European regulations. And so the standard for this would be this HEN 18031 standard. And this is at least something that you can now have a look like what you need to do to comply with this radio equipment directive, for example. And so, yeah, there's also all the features that you need to implement. They are really fuzzy, yeah? And then this is currently a big challenge. So you don't really exactly know what to do. Actually, this standard, this 18031, it's like a decision tree. So it's very hard to read, but there are also tools to get along with that. Yeah, but then you can say, okay, if I follow this track and the end is maybe yes or no, then I know if I do comply or whether I need to go up and change something to go the other path. Yeah, so this is the one thing, like for everything that has a radio, like Wi-Fi, Bluetooth, and so on board. And this is applicable already this year. And if you don't fulfill these things, you're not allowed to put your CE stamp on your product, and so you're not allowed to sell it in Europe. So this is kind of big change for some producers here.
It's good that these security standards are becoming clearer, as you say. We probably need a bit of support, I guess, to sort of help us through all that documentation and understand what it all means. For those people who've not really taken the time to understand what security really is, what does security actually mean for an embedded system? Is it, for example, good enough to know that you've got a security algorithm available in software?
Maybe if you can also go back to the slide that you just shared. The next thing that is coming up is the Cyber Resilience Act, and here it's actually the answer is somehow in there. So it's not enough to just put some features onto your product, but you have to think security from the plan, design, develop, produce, shipping, and maintenance phase. So actually you see, so security has something to do with planning, with maintaining, and so it cannot just be an algorithm or something like this. So it could, for example, be take a good algorithm, but be prepared that this algorithm might change in the future because some attacks to this become widely known, for example. And this then lowers your system security. So this is just one example, but so, quick answer. So it's not enough to just have a certain encryption or whatever going on. You have to derive certain security goals, for example. If you think of a system that's somehow out there and is doing a certain task like measuring data, sending it to a backend, for example, then it needs to have some keys to send the data to the backend, for example, and you want that this thing is working for like 10, 15 years without any maintenance or without anyone needing to go there. So you need to do some maintenance to the device, but maybe not physically. So these things you have to consider, and if you think, okay, if somebody could go to your device, for example, like these power switches here. So here it would be very easy to just like solder some wires on it, and then you can read out all these credentials. For example, you can change the config, and then you can put it back and give it power again, and then maybe it's sending the data to the backend, but maybe they are multiplied with a certain value, or it's also sending the data somewhere else. So this security goal to protect here would be like system integrity. Yeah, so it's not the functionality, but it's the integrity, so that nobody in the future will be able to go there and change the system, and that you can be sure it was not changed or was not tampered. Yeah? So this is something that many times is forgotten, because it's also not really easy to do. And one measure here to do would be secure boot, to compensate with this attack, or to mitigate this attack. Yeah, and also sometimes, many people don't know how easy it is to retrieve assets from a device, like reading out a SD card or an eMMC storage. It's really easy on most of the devices, and so everything that is on this disk, on this eMMC, so internal soldered storage or maybe micro SD card, can be easily get out. So this could be Wi-Fi credentials, VPN credentials, your AWS account, or whatever. Yeah, and also like the applications that are running on it, your IP that's in the algorithms. It can be many things, and you have to define like what assets you want to protect against what. So what should be confidential, what can be seen but maybe should not be changed, and then you have kind of a list that you can work yourself through.
Now, one of the things you just mentioned were SD cards. Obviously, they're commonly used in embedded Linux applications for the operating system, and sometimes they're just used for storing and logging configuration data. But there's no real clarity on how, other than maybe encrypting the data as it's stored, that you might be able to protect the data. Can you make such a data storage medium more secure?
Yeah, and as you said, so actually, you could secure it already right now, but you would need to encrypt it somehow. But so actually, where is your encryption key stored, and how is your encryption key getting like initialized on this device? And I think these are the challenges then for many manufacturers. So if you always use the same key, this key could get leaked, and then actually you don't have much security. So maybe to just like briefly introduce our idea or vision, like what we do is we have. You can consider it, you have your embedded system that wants to send data to, or want to save data to a flash card. And between this card and your computer, there's like a guard system. It can look like who wants to access the data. Does he want to read or to write, and so on. And depending on whether you think this is okay or not, this guard will just say, hey, no, that's not allowed. And actually, this kind of feature we have built into our micro SD cards, and so it's not really like an extra computer, or firewall program that's running there, but it's built into our flash controllers. So our flash controllers have extra features that are not part of the SD card standard. So we can do, for example, encryption on the flash. We can do hiding, so like not obscurity hiding, so really vanishing a whole partition or memory area, and only if you can log into this card. So as you see here, this green access, so this means you have to first authenticate against the card, and then you will be able to use a certain area of the flash. And besides of just like hiding and so which would be more confidentiality as one security target, we can even also say some flash areas are read-only, or maybe read-only if you're unauthenticated, but if you're authenticated, then it's read-write. So you can totally flexibly configure these cards, and with this read-only feature, you can easily do this integrity protection. You can say, hey, all my applications are on a partition that cannot be altered by design. Yeah, so it's just not possible. And you can even also like totally do it unalterable by entering this PIN or whatever multiple times wrong. Yeah, so then even we as Swissbit, we don't have a way to change this behavior of the card. So it would be really always the same, like you decided in the production line, and you can be sure if it's powering up, it's always powering up with the same software that you decided to be placed on this device. And that's special, I would say.
And that's exactly, yeah. I think that's, one of the benefits of the system, that proper security is really hard, and there's so much discussion about that at the minute. I think one of the things that the UK government is trying to do, which I read just recently, that they're sort of essentially creating a backdoor into security on Apple devices. I think that's a good example. And you need to be sure that when you're implementing your security, that backdoor doesn't exist, obviously. And so looking at the SD card design that you've just shown us there, one of the challenges I think it throws up immediately is for the software development team. They're going to need to change their software development approach to accommodate such a secure SD card. Can they start development with a non-secure SD card so that they can do rapid software development and debugging, and then sort of switch the secure version later? Or should they really be looking at using a secure SD card right from the very beginning, or at least an early stage of the development process?
So I would say they should always use the secure card, but it's actually not mattering so much. Yeah. So and also our cards. So I've explained this also in our community portal. So they have kind of a configuration or life cycle. Yeah, you can if you get our cards, they are working like any normal micro SD card. So they're in the so-called transparent mode. You can flash everything on it. You can do partitioning. You can dump everything. And also in this card, this would be like one special use case, for example. So here, this would be a card on the left. Yeah, sees these disks. So this would be the 4 partitions, for example, boot, rootfs, appfs, and some credential partition. And in this case, it would be already configured. Yeah? So here you would need to change something. And actually, the major change would be that you set the boot partition. So all the code that needs to be known by the system to boot up, it's publicly readable, yeah? And it needs to be, because it needs to run the initial software. But then you somehow have to do this authentication against the card. And only if this is working, then you would see the rest of the partitions like rootfs, appfs, and credentials. So if you want to protect a system like this, so this is called secure boot, and we did an implementation for the Raspberry Pi. Yeah? So this is also reference code that we have. We can show it to you, and we even managed to secure the Raspberry Pi, yeah, with also an external pen test. So this is something that's special. This takes some more effort, I would say, if you want to completely do this, but we have references for it, and we have partners that can help you with implementing this. The much easier approach would be if you just consider this as an external storage, like for kind of a industrial PC or whatever. So this is like the very, very, very easy use case. Yeah. So you have a system that's normally booting up, and sometime you just run a script that will send this unlock pin or password to the device. Yeah. Very easy. So it's just a command line tool or something that you can implement into your applications. So we provide you with the commands that are needed, and it's open source, like what you need to unlock this. You just send the command with a challenge response mechanism, so it's also replay safe. And then this card is unlocked, and you can write to it. You can read from it. And the greatest thing here is, as soon as an attacker is now taking out this card, it's losing power, obviously, and this is locking the card automatically. So if you plug it in after that, all the data that you've decided that shouldn't be visible, they are not visible. Yeah, so you need to re-authenticate again, and this is like the intrinsic security feature here. So you can very easily unlock it if you have these pins and can do the authentication. But as soon as somebody is going there accidentally or not taking out the card, it will not be readable. Yeah, or only to the extent that you have decided to be readable. And that's actually it. So I think this thing here is implementable on any Linux system in less than a day. And the Raspberry Pi use case I've showed earlier, so with the secure boot, I think this is also doable in one day. We have videos for that, training material. We have the source code, everything you need to download. And as I said already, so we also have partners that do this for other end customers at the end. So they just have a project, they need to have their systems more secure, and they can do this for you.
Now, for someone who's sort of new to security, what's the best way to get started to really understand how to implement it? And do you have some sort of development kit for this PS66U secure SD card?
Yeah, so I think this was one of the challenges, and so like when I started in the product management here with Swissbit, so mainly we did projects for big industrial companies where we do one-on-one consultancy. But I decided to make it a little bit wider and opener and explain the features that we have more in detail. So this is one thing, and so because you as a security responsible, you have to know how the security mechanism is working. Um, and also, finally, if you need to go to some notified body and have to explain, hey, what is your security concept and how is the Swissbit part playing a role there, you need to know everything in detail. So I think end of last year, so around with the launch of the security level 2 micro SD cards, we also launched the community portal. And this is kind of an information gathering or knowledge base where we have videos, tutorials. There's even a whole YouTube playlist on different levels of technological background. Yeah, so one is explaining, for example, only how these features are working, how this protection profiles are looking, and why, for what you could use them. But we also have videos that really explain step by step what you need to do to make a Raspberry Pi secure. Like, what do you have to copy where do you get the files, and so on. So I would highly encourage everybody to go there and to have a look, like what's already existing. There will be more and more videos also coming. And in the future, there will be also the opportunity that you can also really use this community thing like a forum, that you can ask your questions, and that we also take care that we document some features that maybe are not very easy to understand in the beginning, that we enhance the documentation.
Well, that sort of brings us to the end of the questions that I had planned for you, but we've also been reaching out to our community to find out what sort of what they want to know about security in general, and also about this type of product. Now, in the introduction, I mentioned the Flipper Zero, which is sort of basically a tool that tries to hack communication over wireless links. And if I summarise some of the questions that I've been collecting, there's a lot of interest in, side channel attacks. It's nice that we have, for example, secure trust zones and things like that on microcontrollers, and we're able to stop flash being erased or read. But there's people out there trying to break those systems. Can you explain, for those who've not come across it, what is a side channel attack, and how does a supplier like Swissbit go about making sure that they're ineffective?
Yeah, so actually side channel attacks, so you have to think like you do proper security already. Actually, you think you do this, so you have the best algorithms, you have maybe a good key derivation or key management in your production line. And then maybe by accident, somebody is seeing the power. So if you calculate something with your keys, then maybe you get power fluctuations that depend on the data that is shifted into this algorithm, for example. So this would be one side channel attack. But there have been even things known where someone is just viewing at an LED of a computer with a webcam, and because of this fluctuations of the LED, you could see that, or like you could somehow recalculate what the key and the algorithms and so on was using in there, or maybe acoustic radiations of something, or radiations of a cable or whatever. So side channel attacks are really, somehow I would say hard to completely circumvent, but actually there are devices that do exactly this for you, and this would be like secure elements or HSM, so hardware security modules, or TPMs in your computer. So they do at least these crypto things, and normally they also have very good side channel hardening inside. And this will be also coming, so if I may say this, so this will be coming in the near future. So we also have micro SD cards that can integrate these secure elements, for example, so that you can say, hey, I don't have to care that I have an algorithm that no matter like what key is calculated, the power readings are always the same. So you can do this in software, but this is already done inside of these small microchips. Yeah? And they also have better and proper random number generators and so on. And we can integrate this also in micro SD cards or eMMCs. And then you can also just retrofit and plug it in your embedded system, and don't have to worry, at least not about this type of side channel attack then anymore.
One of the other areas that came up as well was, as you've already sort of mentioned, Linux-based applications on Raspberry Pi, that's a good example of a single board computer, an SBC, where this type of SD card could be used. But then there's also within the community sort of interest in maybe using this type of product with a standard microcontroller. Some microcontrollers just have an SPI interface, some actually have a proper SD card interface, but maybe don't run an operating system. Perhaps it's like a bare metal real-time operating system. Is there support for using the PS66U with that type of microcontroller without embedded Linux?
Yes, there is, but I think it's not made public yet. But I'm also thinking if I have one device here. So I did a POC for the ESP32 camera module. So there you have a micro SD slot. You can easily talk to the micro SD card, and so all the commands that are needed to the low level communication, like to how to say, hey, give me a challenge, and then if you can take this challenge and put your authentication thing with it, and then send it back. So these things will be also published soon if it's needed right now, and maybe not published by the time you see this recording. Just get in touch with me. So that's definitely doable. So it's low level communication. It's open source. So you just need to maybe know how you do this. We also have some customers that currently are implementing this with free RTOS. So that's totally doable. And also we have some cards, so depending on what is your use case, we have some cards where this is just working out of the box without the need of any special things. So like we have camera or archive cards for drones, for example, or body cams. They just record. They don't know that it's a special SD card, but as soon as you take the card out and put it back in, the data is all encrypted. And only you know how to retrieve it. Also, the embedded device cannot read it because it's encrypted. But sometimes that's just enough. Yeah? So if you just want to log data and want to make sure that nobody is able to retrieve this, no other than you, that's the way to go. You just need to only send files, and then you don't need to do anything for the security.
Right. Now, you mentioned earlier about the community website where you've got sort of examples and videos, and I've taken a look at it myself, and it's really well put together. So it's nice to see that level of support already in place. But there'll definitely be other customers, maybe development teams, that really need a more hands-on approach. Do you sort of have consultants in the field or partners who can help? And are you looking for more people that can help in that area at all?
Yeah, so we already have quite some partners that used our products for their end customer projects, I would say. And these partners also can support everybody that's interested and would need this. This will be soon published on our website, so that you will find a list, and maybe by the time that you see this, maybe you can go to the community portal and check out the potentially already existing partner list, where we say like which industries are these partners familiar with, which kind of projects or like embedded devices they already are familiar with, or for example this question like free RTOS or Linux devices. So you can check this out and then get in touch with them directly, or you can also reach out to us and maybe ask us like what partner would be appropriate. And these partners, they also are backed by our application engineering team, which can also support if it's kind of a bigger project, then also Swissbit is supporting here. But our partners and our documentation, I would say, is the first step to go.
Maybe let's just end on one slightly more personal question. You mentioned already that you're a security consultant. How did you get to that stage, and what would you recommend to anybody interested in learning more about cybersecurity and exploring how it's all implemented? What's the best approach, or what's an approach to work along that path and get into this area?
So actually, I must say I did not do any training or whatever, so nothing really. So maybe some ethical hacking, so for operations security or stuff like that, but not really like how to get your embedded devices secure. So actually, what I think is important is that you have a technical background of the Linux or whatever systems directly, so that you know the technology basics. And then you should go to see some videos of like hacking conferences to see what's possible, because I think this triggers the creativity, and hacking is only about creativity, using systems in a way that they were not designed to be used. Yeah, and you can abuse the system, yeah, and So this is one thing, yeah. And the other thing is just try to change the perspective. So if you are a developer for a product of your company and you do this for 20 years or 10 years, just ask somebody, hey, take an asset, and then you can ask this guy to, hey, how could you somehow retrieve this or change this or whatever? Yeah, they will find a way because they know their systems so well. And actually, that's the major thing. You just need to change perspective, and you will see there are some ways how you can get to certain things. But most people are not really aware like what's doable. Yeah, that's one thing. So this is something that you can learn from like Chaos Communication Congress or whatever kind of or Black Hat or whatever videos that you can also watch for free. Yeah, so this was very inspiring me during all my business trips actually. So it was a very good learning resource. Yeah, and then like technological backgrounds. Yeah, and but that's mainly the red teaming, yeah. So like, what can you do to get in? But the opposite is a little bit harder. Like, what can you do against this? And there you have to somehow find your way, read best practices, and yeah, and communicate with people. I think this is also very helpful.
Fantastic. Well, Roland, thanks ever so much for your time and all those insights into the topic of secure SD cards. I wish you all the success with the PS66U, and hopefully you'll be at a few trade fairs in the coming months to talk to people and explain its functionality to them in a bit more detail and answer some of their questions directly.
Yeah. Looking forward to it. And also we have like, also if you're interested in this regulations thing, so we also create webinars where we tell like what's coming up, what should you do, what can you do, and also like not really Swissbit messages, but from our partners that are also consulting in this area. So yeah, just go to our website and see what we are doing, and also maybe go to my LinkedIn page and connect to me. That would be great.
Fantastic, thank you. Well, that's all we have time for, so let's review what we've discussed. It's probably fair to say that for too long we've relied on the fact that embedded systems seem like too much trouble to hack. But the stakes have risen, and a simple wireless camera can contain secrets such as a Wi-Fi password that provide access to much more valuable information. Regulators are well aware of this, and in regions like the EU, you'll soon be required to implement proper security. One glaring source of plaintext data is SD cards, but now Swissbit with their PS66U have developed a secure SD card device. With its encryption capability, your data is protected from hackers and prying eyes, while also offering plenty of flexibility to ensure ease of use according to your application's requirements. As you'd expect, there is plenty of support available for developers as well. My thanks go to Roland Marx from Swissbit for sharing his technical insights on cybersecurity and secure SD cards. If you'd like to learn more about the PS66U, follow the link to the Mauser website.